So we're gonna start with a quick trace of the algorithm that we did on Monday. Okay, just so that we can see whether it works or not using a trace. Um, I might change the code a little bit here, just so that we don't go through like three function calls. I think one is more than enough. So which one do you want to keep? In other words, what is the score that you want to convert into a letter grade? We don't have to go with any one of these three. We can add an additional one if you want to. Hmm? Just the point three? That's a pretty easy one. Do you, yeah, I think the point seven is a good one. Okay, so we'll keep that one. I'm using slash slash, that's commenting. So that means, anything, any line or any content on a line that is on the right-hand side of the slash slash is not going to be read by the computer. It's not interpreted by the computer. And we're gonna make this, not exactly seven. We'll make it. I think point seven is good. It's a boundary case. So let's go with this, and it is going to take a little bit of flip-flopping, just because the screen size is not quite big enough to do all this. So we'll go ahead and see what we can do. And we're gonna say new under Google Sheets from my own template. Okay, create it. And then after this, we're gonna go over the three questions that I have posted, for the final exam. So we'll do that too. All right. So what we are going to do here is we are going to specify, come on, let me type something. Okay, there we go. Label, value, and right. So it is going to be from line three and down. So it's going to be A3 to, I don't know. We'll just give it up to K for now. All right. So we have comments. We have line number as usual. And we're going to get started with the precondition, which has nothing to say anymore these days. Um, and I can pull this down a little bit like so. There we go. I'm just trying to scroll it so that we only show the portion that is important to us. Ah, okay. All right. So this is the code, okay, and we do have line numbers. So let me go get some clean line numbers by copying and pasting this into a new document. So all the lines you'll start with line one. There we go. All right. So this is a clean copy. The first line that we need to execute is line 12. Okay, it doesn't really do anything. So line 12 to um, line 13 really do not do anything, except for creating the local variables, and that also includes line 14. So we're gonna put a whole range here, and we create the local variable. Oh, okay, it thinks it's a date. There we go. All right. So now we start on line 13, which is the definition of local variable x. And then line 14 are the thresholds. So instead of using the usual way to do it, I'm going to use thresholds. And then bracket 0 is here, and it has a value of zero point 0.6. And then bracket 1 is here. It has a value of zero point 0.7. Just to save some space, because otherwise, thresholds bracket 0, thresholds bracket 1, that's going to take up a lot of room. So I'm just trying to save some space, because we are going to need some space here. So zero point 0.9, there we go. So now this time I can shrink these columns like so, and then column C does not need to be that wide either. All right. So all of these columns, correspond to threshold. So, one way to do this, okay, it just doesn't show very well up here. Um, it wants to, I'm not sure what to do with that. Okay, I guess that's still not very good. Hmm. Okay, we'll deal with that later. Um, so those are the local variables. And now we can proceed to execute on line 17 because line 15 and 16 are commented out. So we continue on to line 17. So line 17 needs to update local variable x, which starts with an unknown value. So we have to put a question mark here. And the value that we want to use to update variable x is, the return value of um, score to grade, the call to score to grade. So whenever you call a function, whenever you invoke a function, you always need to construct, a bunch of columns. And in this case, the columns will correspond to all the parameters. And then we also have to keep track of, where do we return to? And when we return, what do we need to do? So we'll keep track of all the parameters. So we have score, we have thresholds, and what else do we have? Num thresholds. There we go. So I'm going to abbreviate it here just so that it doesn't take up too much space. It's not too big of a deal. We don't have recursion in this case. And then we also have return so that we can keep track of where do we return to, and what do we do when we return to that spot. So now the next thing we do is to process all the arguments. So the point 0.7 argument, which is a value, is specifying the value of the parameter called score. So this one starts with a value of zero point 0.7. And now we can shrink the columns a little bit so it doesn't use up as much space. Threshold is going to be, um, so we are using the local variable thresholds in order to pass to the parameter thresholds up here. So they can have the same name. There's no problem with a parameter having the same name as a local variable of the caller. Okay, so this is the caller code, and this particular thresholds is referring to the local variable thresholds here. But we are using it as an argument to specify the value of the parameter thresholds of score to grade. And because arrays can only be passed by reference, so that means when we pass thresholds as an argument to a function, we are only passing the start column. We only let the callee or the function being called, we can only let it know where it starts. So in this case, it's going to be a reference to column D. And then we move on to the number of thresholds, which is really just a constant of 4. So the constant of 4 is used to specify the parameter called numThresh or numThreshold. Now we have to specify the return information. In other words, where do we return to, and what else do we have to do once we return? um, we have to return back to line 17. When we return back to line 17, we would have resolved the function call. So this whole thing becomes a value, and then we just need to change x to that particular value. So the way we specify the return is going to be, we're going back to line 17, and what is left to do is x equals to the question mark. The question mark is a placeholder of the function call that we're dealing with now. Do we have any questions at this point about how the columns are set up when we call the function called score to grade? We are good. All right, so we are all good at this point. All right. So now that we have set up all the columns, we can now continue into the function. The function starts on line 1, even though it doesn't really do much. So between line and 2, we are continuing the execution. There's a local variable called row number. The row number is we reserve a column for row number once we get into the function. So it is the job of the function being called to allocate a column called row number. That's the job of the callee. And as a local variable, it always starts with a unknown value to begin with. And then once we continue on to line 3, local variable row number is going to change to a 0. And then we can continue. And I forgot to make this, I have to extend it to one more column to include row number. All right, so now what do? We move on to line 4, but line 4 doesn't really do anything. It's just a marker, so you can skip line 4 if you want to. And we just start with line 5 and evaluate the condition of line 5. It's a little bit long because I used pretty long names for the variables. So this is supposed to be just score, or I can change this to, eh, I'm just going to change the code here, change this to score because it has to refer to this thing here. Um, right, okay. All right. So now we have to use the comments to kind of specify score is greater than threshold. I'm going to abbreviate, here, just because otherwise it takes up a lot of space. So the question is it true or is it false? So score has a value of zero point 0.7, okay? And we're trying to compare that to element row number. Row number is 0 at this point. So we are referring to element 0 of the array that starts at thresholds. Thresholds as a parameter tells me where I can find the first column of the array, which is column D. So this is column D. Column D is element 0, and we are in fact referring to column 0. So now we are basically comparing score, which is zero point 0.7, to threshold at row number, which has a value of zero point 0.6. Zero point 0.7 is greater than zero point 0.6. It's true. Okay, so we just say it is true, which then allows us to continue into the then portion of the conditional statement. The then portion of the conditional statement is on line 6. All it wants to do is to update row number by incrementing it by 1. So row number goes from 0 to 1. And then we get to the while, which is on line 8. So on line 8, we have another condition to evaluate. In fact, we have a pretty long, complicated condition to evaluate in this case. So let's take a look at the condition here. The first thing is asking, is row number greater than or equal to the number of thresholds? So we can take a look. Row number at this point is 1. The number of thresholds is 4. 1 is greater than or equal to 4 is false. So if the left-hand side of an OR is false, you have to evaluate the right-hand side. The right-hand side is now asking thresholds 1, is that greater than the given score? The given score, I should change this back to just score. I fixed all this, when we worked on the C code in online GDB, but then I did not come back and fix these. So row number has changed. Row number is now a 1. And if row number is now a 1, then thresholds at row number is referring to the first element, or I take it back. It's the second element, which is also known as element 1 of the array that starts on column D. So that would refer to the value of zero point 0.7. So what we are asking now is zero point 0.7 greater than zero point 0.7? The answer is also false. Okay, so we now have false because the left-hand side of the OR, this is false. The right-hand side is also false. So false or false is the whole thing is false. Very good. But we have a negation on the outside. So even though we know this entire thing in parentheses is false, but because we are negating that, not false is true. So that means the while loop is going to go back and go back to, so I'm going to have to say the condition It's long. Do you want me to type the whole thing, or are you guys okay with just kind of an abbreviation? Abbreviation? Okay. So row number is greater than equal to num thresholds is true, is false. Thresholds row number is greater than score is also false. So this entire expression is false. Oh, it's true because we negated. So because it is true, then where do we go? Hmm? Yes, that is correct. Okay, because it is a while loop. Once again, the way you read while is it is the same thing as long as. Okay, so that means when the condition after the while is true, then you have to go back. You have to perform another iteration. So that means we go back to line 5. Okay, so we're now back to line 5. Row number is still 1. So this time we are comparing the score. Oops. Okay, forgot to switch back here. So we are now comparing score, which is still the point 0.5. Threshold's row number is also just point 0.5. So now this is false, which means we have nothing to do. And if there's nothing to do, then we exit the conditional statement and we end up on line 8 again. Hmm. Oh, so equal to. Very good. Okay, thank you. Uh-huh. That's good. Okay, it's greater than or equal to, which then is true because yes, zero point 0.7 is greater than or equal to zero point 0.7 is actually true. Thank you. Good job. Good catch. All right. So if that condition is true, then we continue on to the then portion of the conditional statement. So that would be line 6. Line 6 is going to increment the row number again. So the row number is now going to be a 2. And then we go to line 8 again to reevaluate the condition. But this time, because row number is now a 2, so this side is still okay because 2 is greater than or equal to 4, it's still false. Okay, so we don't have a problem on the left-hand side of the or, it is false. But then when we evaluate the right-hand side, if we are now looking at element 2, which is the third element of the array, and uh, uh-oh, this is not working because array result was not expanded because it would overwrite the data in A2. So I made a mistake somewhere. A2, okay, there we go. All right, so we are referring to the third element or element 2 in the array, which is point 0.8. So point 0.8 is greater than score, which is point 0.7, is true. So that means we have false or true, which is true. But then we also negate the entire result. Not true is false. So that means this entire condition is actually false this time. So basically what we need to do is to copy and paste it here. And then this time we say the answer is false. There we go. So if the condition specified on line 8 is false, we exit the loop. So we now continue on to line 9. Line 9 says return row number. So we have to take a quick look at row number. It has a value of 2. So 2 is the value that we have to return. So that means we have to take a look at the return column, copy and paste it over here, and then we change the question mark to the value that we are returning, which is 2. And then we copy and paste this again to over here, just so that we know that we have to go back to line 17 when this is all done. And then it's time to deallocate all the um, parameters, the return, and also the local variable pretty much at the same time. So now we go to column H, paste all this, strike them out so that we know that all of these are now deallocated. Execution now continues on to line 17, which is really just x equals 2. Okay, that's pretty easy to do. Column C, which is corresponding to local variable x of main, is going to update to a value of 2. And then we proceed to line 18. line 18 is a return 0. So that means we are now done with the main function. And so that's why, all the local variables of the main function is going to be, they're all going to be deallocated at this point. And then we get to post, and that would be the result of tracing this code. So are we doing okay so far with the code that we wrote on Monday, which converts a score to a grade? So we good with that? Okay. All right. So shall we move on to talk about the exam questions? Okay. So the exam questions are in this particular spreadsheet already, and I believe all of you have access to it already. So we'll go ahead and check that out. Okay, so I'm gonna right click, open it in a new tab, and all right, cool. Okay, so I know you guys can get into it because there's an anonymous camel already there. All right, so the exam, at least the exam on uh, the the last time I taught this class, okay, the final exam consists of, I give you traces and you have to reconstruct the program that gives you this particular trace. So instead of me giving you the code and you give me the trace, I'm flipping everything around. I give you the trace, and then based on the trace, you have to give me the original code. Okay? So we'll go ahead and take a look at, how do we do this. Okay? All right. So to do this, I'm gonna need an editor. So let me go start an editor over here. Um, Mouse pad. There we go. Oh, okay. So it's gonna be the same one, but I'm basically adding a new file. All right. So we are starting on line 7 over here. Okay. So what you need to do is to kind of give yourself all the blank lines over here. And then we go like, okay, so what is so important about line 7? In a C or C++ program, how do we start the execution of the entire program? With main. Very good. So that means line 7 is probably the beginning of main. Okay, so you just kind of go like this. Um, hmm, um, well, the way I trace is, I usually start with the line that um, has the function definition, which is, in this case, that's what it looks like. There are some fudging rooms too. I mean, you can move the open brace, from one line to another line, that's okay. We also know one thing, okay? Because line 7 says, okay, let's go ahead and reserve column B for something. Why would I do that? It makes V a local variable. Very good. How do we know that V is not a parameter when we are calling something else? It it does not have a return. Yep. Because if V was a parameter, then we would also have return allocated on the same row, but we don't. So that means V is really just a local variable. The other dead giveaway that V is a local variable, it starts with an unknown value. Parameters do not start with unknown values. Only variables do. So that's a dead giveaway that V is a local variable. Now, do we know the type of it? Is it a double or is it an int? We don't really quite know yet, okay? But we know that it is a local variable. So this remains to be seen, okay? Maybe we have to change this later. Are we still doing okay so far? Okay. And you can still make it a double. It would not make the answer wrong, okay? It would still be a correct answer. So now we move on to line 9. So when you get to line 9, it says, okay, we're going to allocate a new column, which is column C, and we're going to keep track of some return information. So what is that telling you about line 9? And what is this question mark over here? Hmm? Sorry? Is a placeholder. And under what circumstances do we need a placeholder? Yes. Aha, very good. That's because the question mark is a placeholder so that when the function returns a value, that value goes to where the question mark is, right? Okay, very good. So that means on line 9, we are saying, um, how do I know this is starting with v equals something? Because the return column tells me what I need to do when I get back to line 9, which means on row 6 of the trace, this is telling me most of what I need to know about line 9. Okay, the only thing I don't know is the name of the function. Okay, so we'll say this is just going to be some kind of function, and you can give it a placeholder. Okay, so we can just call it mystery function. And mystery function is not going to have any parameters. How do I know that there are no parameters? If there were parameters, where would those parameters have gone? Well, but that's only if you have access to the source code. We're only looking at the trace. If you just look at the trace, how can I tell that the mystery function does not have any parameters? Yes, that's the question. How can we tell that the mystery function does not have any um, parameters? Yes, yes. I would have columns allocated to the left-hand side of the return column, but on the same row. Okay, so that's how we can tell that the mystery function has no parameters. Okay, now can you really tell what is the name of the function? The answer is no. Okay, so for things that you really cannot tell, okay, I cannot tell what the name really is, just kind of replace it with mystery or, whatever, name you want to choose to use. Yep. Well, it has to be a legal name, so it has to be a valid C identifier. So the best way is just to say mystery one, mystery two, and so on. Hmm. All right. Okay, so this is good. And now, but how do I know that, it's not just a call to mystery? How do I know we are also adding the return value of the call to Y? It's because it's spelled out here. Yep. Hmm. So now we go like, okay, where's the next line? The next line is going to line 1. So that means mystery is defined here. So mystery has to be returning something because otherwise it cannot be replaced by a single question mark here. So it must specify a return type of int or double or something like that. Now, if you use double, it would not be wrong. Okay, but int is the easiest one that we can use. So I'm just going to use int here. So this is how we can tell that the definition of mystery starts with line 1 because that's where we went when we called the function that was represented by the question mark. And then we can see that line 2 here is already doing something. So that means, I'm going to put an open brace here because line 2 is a particular kind of statement. So um, what kind of statement do you think is on line 2? What is the effect of line 2? If you look at row 8 of the trace, what does line 2 do? It's changing a value, right? What is it changing? It's changing the question mark to 12. Okay, that means mystery is just returning 12 because that statement will change the question mark to a 12. That's the job of a return statement. Copy and paste the return cell, return column, change the question mark to whatever value you're supposed to return, and then copy and paste the modified one to one row below, 2 rows below where it is, so that we can remind ourselves where are we supposed to go after line 2, and then we also deallocate the return column, which is consistent with what the return statement does. Are we good so far? And hmm? Yes, the trace itself is. Yep. Yeah. And then we put a end brace here because or if I mean, if you want to really push it, you can put an end brace here too. Okay, to C++ does not care. Okay, but typically in the class, I put it on the line of its own. So I think we should be good. We should be good here. All right. So in terms of the trace, now we move on to line 10. Okay, excuse me, line 9 again. But line 9 now looks like this. Okay, we got line 9 figured out already, so we're good. And then it set up a return, and that's because we're calling y. And function y starts on line 4. So now we go to line 4 and go like, okay, this is where function y is going to be located, and with an open brace. Line 5 is a return statement. We know it is a return statement because this is the effect of executing line 5. It is copying and pasting the return cell, changing the question mark to a constant of 6. So that means, okay, so we know that this is just going to return a value of 6 or constant of 6, and that's all it's going to do. And then we get back to line 9 again. Line 9 is updating local variable v with a value of 18 because we get the 12 from calling mystery. We got the 6 from calling y. And then on the next line, which is line 10, um, it is deallocating local variable v. So that means line 10 has to be the return 0 of main, because that's what we do when we get to return 0 of main. We just go like, okay, let's deallocate everything and we are done. And that's why the next line is just another embrace to stop, to kind of close the definition of main. Is that okay so far? Okay, so this is it really involves a lot of reasoning, but you need to understand the mechanisms of calling, returning, what do we do when we call, what do we do when we return, that sort of thing, so that you can kind of go like, okay, how do I backfill the empty lines with stuff? So once again, this is not the only solution. If you want to use a double for over here, and over here, that would be fine too, okay? Because as far as we are concerned in this class, double can represent everything int can, but not the other way around. Okay, every integer is also a real number, but not every real number is an integer. So that means if you really want to be safe, you can always use double, but for the most part, we are sticking with integer. It will be fine. The other one is how we name the function, because in the trace itself, there's no way you can actually tell how this function is named. So as long as you name it correct, as long as whatever name you choose here is consistent with the name over here, you'll be fine. Is that okay? So there are things that you may not be able to fully resolve looking at the trace, in which case you just have to pick one way and just kind of do it consistently. Are we good so far? Well, I'm just tracking, how it was done the last time I taught this class, which was 2019, and all questions are like this. Yep. hmm Well, I mean, with varying degrees of difficulty. So this one really is just testing, do you know how to call a function, and do you know what return does, at the end of a function? So are we good with this one? Shall we move on to the next one? Yes. Huh? Line 4 and 5. It's because here it can. So this is a function call. Okay, we know it's a function call to y because the function call of y is replaced by a single question mark. So whatever row 12 of the trace is corresponding to the invoking of function y. And because we know that we continue execution on line 4, and by the convention that we have been using in this class, that means line 4 is the beginning of the definition of function y. And that's how I know line 4 is the first line of the definition of function y. And then line 5, is changing the question mark to something concrete. So I know it is a return statement. Mhm. All right. So are we good so far? All right. So now we move on. Okay, we are recording. Okay, just in case you need to listen to the whole lecture again, I am recording and I'll upload it at the end of the lecture. Yes, go ahead. Oh, okay. All right, cool. Yeah, yeah, it's good to look back and then you can then, derive, a method on your own. Okay, how you can because I can describe it. Okay, but are you going to read my description of how to do this? Probably not. So you have to listen to how I do this and understand the principle behind, how I can reverse engineer the whole thing. And then you can write it down in your own words, so that you can follow your own instruction in the final exam. All right, so this is all done. We'll move on to um, the final exam question number two. Same nature, okay? It is, a trace. So this time execution starts on this doesn't look right. Oh, okay. So this time is kind of interesting because execution starts on line one. But we know that in C++, you have to start with the main function. Okay, main function is the entry point of everything that you do. So because it is starting on line one, because row two of the trace says, okay, we are starting on line one. So that means that's where main is. Does that make sense? Okay. So we also know that main has three local variables. They are x, y, and z, respectively. So we can now say, okay, we got three local variables x, y, and z. Um, and then we move on to line three. Oh, line three is right here. So is that okay? Does everybody understand how I can figure out line two of the code is just the definition of local variables x, y, and z? Okay. We good? Okay. And I know they're kind of I can get away with just integers because when I look at the whole trace here, all the values of x, y, and z are integers, right? So I go like, okay, that's easy. Okay, just make them integers. Now, is it wrong if you change this to a double? The answer is no, it is not wrong. It's just not necessary. But I won't take any points off. So, but I prefer to stick with integers here. All right. So that's so line three. Okay, what does line three do? Line three here, which is represented by row four, the only thing it changes is x and it changes it to a three. So the quickest and easiest way is to say, okay, x just get a value of three. Next line, y got changed to a 2. Okay, that's the easiest way to do it. So does that mean that you cannot do something like this? You can do something like this. Okay, you can make something that is simple to be more difficult than it has to be. Okay, I won't mark this wrong. Okay, it's just like, well, yeah, it is okay. It is still consistent with the trace. It's just like it's a little bit more complex than it has to be. So I personally just prefer to make it as simple as possible. And then we move on to line five. And once again, this is the easiest way to do it. But if you really want to make it more difficult on yourself, you can kind of do something like this. That actually works. Even though z has an unknown value by the time we get to line 5, whatever value z has, if you subtract that from z itself, it's guaranteed to be a 0. So that will work too. But once again, this particular answer is more complicated than it has to be. The simplest answer is simply just to put a 0 here. All right, so now we move on to line 6. Line 6 is having a line of the comments. So now that should tell you right away that it has to be one of two possibilities. Okay? It cannot be a do while loop. Why can't it be a do while loop? Because in a do while loop, the condition is where? Where do we evaluate a condition in a do while loop? Nope, that would be a while loop. A do while loop has the condition specified. Okay, I'll give you two choices. At the beginning or at the end? At the end. Very good. And because this is on line 6 and we already know what line 5 is, So that means line 6 cannot be the end of a do while loop. But since we are also evaluating a condition here, so we know that it cannot be a do while loop. It can be a conditional statement, okay? It can also be a while loop. So now the question is, how do you choose, okay? Which one is it? Is it a while loop or is it a conditional statement? Well, okay, so what is the difference between a conditional statement and a loop and a while loop? Go ahead. Hmm. Aha. Okay, go ahead. Yes, because in the trace we can see that, look at this. We got back to line 6 again. A conditional statement will not do that. Okay, a conditional statement just go like, boop, we're going forward always. So only a loop will go back. And since we already ruled out the other loop, which is a do while loop, the only loop we have left that we have talked about in this class is a while loop. So that means, oh, this has to be a while loop. Okay, so now we go like, okay, since it's a while loop, we're gonna go like this. Okay, and I'm not quite sure where the brace is, so we'll just kind of not place the brace just yet. What is the condition of the while loop? That one is like super, it's dead easy. Yes. Hmm? Because in a do while loop, you need to specify statements and you execute the statements before you get to the part where you evaluate a condition. But in the trace here, line 6 is following line 5 immediately, and I don't have anything in between. Okay. Um, and we also know that it is, line 6 is not the end of a while because if you look at all the line numbers, we never got back to a point earlier than line 6. If it was a do while loop and line 6 was the while part that specifies the condition, then it would have gone back to an earlier point. So that's why I can rule out line 6 being the while part of a do while loop. Are we good so far with all that reasoning? Okay. So now the question is what goes into the parentheses? This is the super easy part. Whatever is in the comments, right? So, y is greater than 0. Okay? That part is like easy. All right. So we know the open brace is going to be here because line 7 actually does something useful. Okay. It updates Z from a 0 to 3. Okay. So you guys remember what I just said. Okay. Make it as simple as possible. So the first attempt some people may try is to say, that's just it. But we know that is not true. Because if that was the case, then Z would not update to 6 the next time line 7 executes. So you can see that line 7 executes the first time, Z is 3. The second time line 7 executes, Z becomes 6. So we know whatever is on the right-hand side of the assignment is not a constant. So if it's not a constant, what is it? Z equals Z plus X. So there are a few ways to do it. Okay, the code does not really clearly state what it is, but whatever you do, Z is on the right hand side as well, and you can also now you can put it like this. Okay, that works too. But the actual, I mean, the better answer is this. Yep. Okay, so that's line 7. And line 8 is doing something too. And line 8 is changing Y, right? But every time we execute line 8, it does something slightly different. The first time, Y is changed to a 1. The second time, Y got changed to a 0. So what do you think is on line 8? Okay, so some people would just put this down. That would be incorrect. Okay, and what is missing here? Yep, the assignment. Yep, because now this is actually syntactically correct. In other words, C++ would let you specify an expression that doesn't update anything, that has basically no side effect whatsoever. It is syntactically correct, but since it does not update anything, it will not be consistent with the trace. So in order to be consistent with the trace, now you have to say, okay, whatever that value turns out to be, whatever y minus 1 turns out to be, is what I use to update y. And then we can see that, when we exit the loop, we skip line 9. So line 9 is most likely just a line that has the end brace. And then um, when we exit the loop from line 6, it goes straight to line 10. So line 10 is our return 0 because we can see that on line 10, we also deallocate all the local variables of main, and only the return statement in main can do that. So now, we just close the whole thing and we're done. Are we doing okay so far? So this particular example illustrates something that's different compared to the first one, because this particular example shows you that, oh, okay, what do we do when um, there are conditions being evaluated? How can we differentiate which control structure we're dealing with, because we could be dealing with a conditional statement, and if we could be dealing with a do while loop, we can also be dealing with a while loop. So this particular example illustrates the logic that you need to use looking at the trace, try to figure out which control structure is responsible for the behavior that you see in the trace. The other part that is also significant about this particular trace is we can see updates of variables, and every time the same line executes, the value changes. Okay, same thing with line 7. Every time it executes, the value changes, which means you can no longer go for the simplest way of the assignment, which is a constant assignment. So now you have to look at, okay, so how can it increment by 3 each time? Or how can it decrement by 1 each time? So typically with these, the variable itself is also on the right-hand side, and we are just making changes to the old value of the variable. All right. So are we doing okay so far with Q2? We good? Okay. Then we shall move on to Q3. Okay, so Q3 is the most complicated one. In the final exam, I am planning to do something, kind of like this, having some easier ones and some harder ones. So that way, I hope most people, everybody can pass the class. And, but I also want to kind of stretch it out a little bit and, kind of see if you guys can handle something like this, which I think you can. Um, so we'll go ahead and take a look. All right, so this is the whole trace, okay? It's a little bit long, and but we're gonna do this, just step by step. So we'll start with line 9. Okay, I don't know why it's loading. Okay, okay, let me just refresh this and see if it works. Oh well. All right, so we'll go ahead and start a new file over here. All right, so the whole program starts execution on line 9. Okay, so that means, on the piece of paper that you have, you just go straight to line 9, and then you go like, okay, this has to be main, because, in C programming, main is the entry point. You have to start with main. So in main, we can see that we allocated 4 columns, 3 of which looks like an array, and one is not an array. So that means, now you have to say, okay, we know that there's an array A, which has 3 elements. And as far as this class is concerned, once again, it can be int, can be double, but since you can see everything in it are basically integers, so you just say int. But if you say double, it's not wrong. And then we have local variable s. Okay, so that takes up another line. So the reason why I know that it took up another line is because the next line after line 9, the next line that actually does something is on line 12. So we are right on schedule. Line 12 is here to specify something that we need to do. So when you look at row 5 of the trace, which is corresponding to line 12 of the code, which we're trying to figure out what it is, we changed a bracket 0 to a 2. So the simplest way to specify that is just this. Are we good so far? Okay, kind of the same logic that we had before, except this is initializing an element of an array. And then a bracket 1, the next line is 7, and then the next line is what? -2. There we go. All right. So now we move on to line 15. Okay. So line 15, which is corresponding to row 8 of the trace, it's got some complicated things going on, right? Um, we can see that we have the return label, or we reserve a column and then label it return. So that means we are invoking a function. Yep. That would not be consistent with the trace then. Yeah, so you want the code that you write here to be consistent with the trace as much as possible. Yep. All right. So we know line 15, sorry. So we know line 15 is calling something. And from the return column, we can actually kind of see what it should look like, okay? Because the return cell here, the one that I'm, highlighting, or the one that I just clicked on, basically tells us, okay, when line 15, when the function call is done, it will provide the value to overwrite the question mark, and then the rest of line 15 is going to be s equals to something. So that means, when I get here, I already know it starts with this. And it's going to start with some kind of function call, and you cannot really tell the name of the function unless you were dealing with something like um, the first program that we dealt with. So I'm just going to call that the mystery function. But we also know that the mystery function has got three parameters because these particular columns are reserved, right before the return. So those are the parameters. So when I need to specify mystery, okay, we can kind of guess that it has a return type of an integer because wherever it goes, updates, s, which is an integer. So that's the return type. And then mystery is the name of the function. And we know that it has three parameters. It has three parameters. In fact, we also know the names of the parameters. One is b, one is n, and one is I. But what we also need to know is what is b? So when you look at b, the way we specify the value of the parameter is it is a reference to column C. Okay, so what do you think it is? Huh? A0? Nope, it is not A0. We can also, hmm, okay, we can also, there's also a clue, okay? There's a huge clue here. Look at this one here. Look at row 13, okay? Row 13 is treating B as an array. Very good. Okay, because you can only use the bracket notation on arrays. Okay, so we know B is an array of some kind. Okay, so we just go like, okay, that's so the syntax to specify the B is an array is just that. Okay, because as a parameter, you cannot specify the number of items in the array because you can never know that. Okay, and then the type of the array has to be consistent with however we use it, which is an integer. And on the other hand is not passed by reference because we can definitely see a 3 here. 3 is an integer, so we would just say that n is an integer. I kind of the same thing because I is 0 here, it is a 1, and when you look at the rest, they're all integers. So we know this is just an integer here. So are we good so far in terms of specifying the types of the parameters of the mystery function? Now, the name of the function, we don't know because the trace never tells you about the name of the function. So that's the one part where you can go like, okay, I want to choose the name of my dog. Okay, that's fine. Your cat, that's fine too. Okay, so now we want to continue, okay, with the next line, which is this is line one, and the next line is line three. Okay, so you can either leave an empty line, but sometimes you can just kind of put the open brace down here. All right. So what does line three do? Line three specifies, okay, in the comments column we have to figure out um, the value of an expression. So once again, we are running into the question of uh, is this a while, is this a if, or is it a do while? So in order to know that, you have to go like, okay, where can we possibly go after line three? And do we ever get back to line three? So that's a very tricky question because we do get back to line three, but we never get back to line three after, in the same invocation. So that means it is a conditional statement because there's no repetition. Now, there is one single case where you really cannot tell whether something is a conditional statement or a while loop. It is when, even for the first iteration, the condition is false to begin with. Okay? Because if you have a condition in a while loop, and even the first attempt of the while loop, the condition is false, then it simply skips over the entire body of the loop and it just continues execution with whatever is next to it, right? A conditional statement would have done exactly the same thing in that case because there's no repetition to help you differentiate, is it a conditional statement or is it a loop? So if the trace looks like that, then you can go like, okay, it can be either one, then I will accept both if or while as a correct answer. Is that okay? So I do want to kind of point out that there are cases where the loop or the trace won't tell you exactly which one it is. But in this case, we can actually tell, okay? Because the condition does become true once eventually, okay? So right here, the condition becomes true, and we just go straight to line 4, but it never got back to line 3 to reevaluate line 3. So based on this, what do we know about line 3? Is it a while loop or is it a conditional statement? It's a conditional statement because it never got back. Okay, so that means on line 3 here, we can now say if blah blah, okay? What do you think is inside the parentheses? Whatever comments specify, right? Because that's the convention, is whatever the condition is specified, we repeat that in the trace in the comments column so that we know what is true and what is false. Okay, all right, cool. So we can see that line 4 is right here. So that means we probably have an open brace right here, and then we move on to line 4. So now the question is, what do you think line 4 does? When line 4 does execute, okay, you have to kind of look at this entire row here. What does it do? So you have to look at what is changed, okay? What is the effect of executing line 4? What is changed? We have a whole bunch of empty cells over here, which means none of that stuff is getting changed, right? The only thing that got changed is this thing here. No, it's not updating the array in any way. Hmm? What type of statement are we talking about? So let's focus on the type of statement, and then we'll focus on the details of that statement. What statement will do something about the return column? There's only a return statement. Very good. Okay. So now we know it is a return statement. Very good. So a return statement is on line 4. So now the question is, what are we returning? No, we are not returning line 6. Okay. Whatever we return is a value. some value. How can we tell what value is being returned on row 24 of the trace? Yes, I do not care about B bracket I. The return statement changes what to the what to what. Yes, you mean row 20? Uh, it is returning a value of 0. Yes, because the question mark becomes a 0. So the return statement is literally returning a constant of 0. Now, can it be something more complicated than that? Yes, but you just need the simplest answer that is consistent with the trace. And I would say just returning 0 is the easiest way to specify something that is consistent with this trace. Is that okay? All right. All right. So I typically put an and brace after this line, okay? But sometimes I don't. Okay, so now we look at this and go like, okay, what about this line 6 over here, okay? When the condition of line 3, then we move on to line 6. So now the question is line 6 after the conditional statement but has nothing to do with the conditional statement, or is it the else of the conditional statement? It can be actually both, but it really is the else, okay? It really is the else. It can be both in this case because nothing can really execute after return 0, so that makes it a little bit special. So now we go to line 6 and we ask, okay, what does line 6 do? So this is line 6, and we look at the effect of line 6. So this means bringing a ruler with you in the final exam can be helpful because these do, I mean, the columns do extend quite a bit to the right hand side. So if you have a ruler, you can easily line up which line you're looking at, and it kind of helps. It makes it easier to identify what kind of statement it is. All right. So when we get to line 6, okay, or row 12 of the trace, we reserved a bunch of columns and kind of specify, all kinds of stuff in those columns. So what do you think is involved on line 6? At least the first time we get to line 6. Uh-huh. Yes. Okay, so we can fill in the first part. That's the easy part, right? So line 6 is going to be return b bracket I plus, okay, and then what do we do? Okay, is it mystery or is it not mystery? Okay, well, okay, it is mystery, but not in the sense that we don't know what it is. Okay, so we know exactly what the function call is calling because the according to this trace, okay, after line 6, we go straight to line 1. What is already on line 1? Mystery itself. So that means we know this is mystery is calling mystery. Okay, so now the question is, what am I passing to the next invocation of mystery? Okay, so now we look at this one here. Okay, when we set up the new column, it is also a reference to column C. So what do you think goes here? It's just B. We just specify B because B is already passed as an array to mystery, and we just pass B along. Okay, so that's just B itself. Okay, what about N? So N, you go like, looks like a constant of 3. Maybe we just stick a 3 here. But you cannot, okay? You cannot just stick a 3 here because the next time I go to line 6 over here, um, oh, N is just 3 all the time, right? Okay. It can be 3, but you can also specify that to be N because N is also a source to get a value of 3. I is the problematic one. Okay, so let me try to get this out of the way. Okay, so I is problematic because every time I specify I, on line 6, The first time it is a 1. The second time it is a 2 because you can see this is also line 6. The third time it is also line 6, I is now a 3. You go like, So we know it's not just a constant. So what is the easiest way so that we can just specify the first time it is a 1, the second time is a 2, the third time it is a 3. I plus 1. The current I plus 1. Okay, very good. So that's very good. So now we completed this whole thing, and we just have to figure out, okay, what else is in mystery. So after line 6, um, okay, so we have to go back to the trace. Sorry, we are on line. Yeah, I have to kind of redo because kind of I added a new line, inadvertently. All right, so we only got 2 more lines to do. Do we have line 7 anywhere here in the trace? Nope. Okay. We do have an open brace to close. We can stick that here. Now, if you give me an answer like this, it's still correct. Okay. I don't have a problem with that. It's just ugly looking. Okay. But it would still be consistent with the trace. In fact, you can put all the closed braces up here, and the code is still considered to be correct because the closed braces do not leave anything in the trace. So that means as long as they are after the statement that they're supposed to be after, they can be on a line by themselves, or they can be on the same line as the statement that it ends with. Both are okay. But in terms of quote unquote proper formatting, it really should look like this. So I'm just illustrating that there are alternatives in terms of what the source code looks like. So there are many versions where it will still be considered to be correct. It's just that certain types of format is what I typically do in the class, but you do not have to go by those rules as long as the code that you give me is consistent with the trace. It's all good. So that pretty much concludes the 3 types of questions that I used in the previous final exam, or the last time I taught this class. The final exam consists of questions like this. All right. So now my question is, how are you going to study for this exam? It is not about memorization, right? I mean, it's open book and open notes. It's not about memorization. What is it about? Sorry? Instruction, structure, okay? Control structure, okay? So there's control structure, there are function calls, right? And mostly it is reasoning. Okay, what can possibly go here? What is the trace telling me? What are the clues that I can get out of the trace? So those are the things that I'm really testing. Is do you understand the material enough to reason with this kind of material and then come up with a reasonable source code that is consistent with the trace? That's basically what the final exam is about. Hmm. Right? So the first thing is you have to be familiar with the forward motion, which is if I give you the code, do you know how to trace it? Because without knowing that, there's no way to reverse the whole thing. Yep. Yes. On line 15, um, yes. So on line 15, sorry, I forgot to finish this whole thing. So the first time when we got to line 15 the first time, we specify reference column C right here. So what do you think the first argument is? What starts with column C? Nope. No, 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 no. We are constructing the column B, but at this point, column B does the column labeled B is not in use yet. We are still constructing it. So at this point, what is column C is the beginning of array A. So when you pass an array, you just specify the name of the array. Okay, that's the first one. This is just 3. Okay, we just do a 3 here. This is just 0. We just do a 0 here. So that's basically what line 15 looks like. When the second time we get back to line 15, we already have the return value. So it just updates local variable s to a value of 7 because 7 turns out to be the return value. And then we get to line 16. So line 16 is also causing all of these columns to be deallocated. So it has to be the return 0 statement of main. So after that, we just have an end curly brace. Now, if you give me something that looks like this with a bunch of empty lines after the return statement, fine, it's not a problem, okay? Because we don't really care about what happens after the return 0 in main. But typically, I just put it right here. Are we doing okay so far? Go ahead. Which part? B of I is not an array. B is an array. Okay, so by itself, B is an array. But B bracket I is referring to a specific element of the array that starts with whatever column parameter B is referencing. So you have to go back to how we pass arrays as a parameter and what is passed by reference. So all of those are actually in the module that talks about passing parameters. So you have to kind of you have to review that. Mhm. I haven't really tried, but you guys are more than welcome to. Is really just to upload the modules that I have written to ChatGPT. Upload also the program, the code itself, and then also upload a copy of the trace, and do it several times, okay, and see if the LLM can figure out the pattern. And then if it does figure out the pattern, you should be able to give it a new program and ask it to produce a trace, and the trace should be consistent with the ones that we have been doing in this class. I haven't really done that, okay, so I don't know whether it can do it or not. So if you try that and it does work out, that means the LLM is able to figure out, what to do when we perform the trace, and then you can ask it to further explain the concepts involved. So, if you find that my explanation is a little too terse, okay, then you can have the LLM to kind of expand on those explanations. So are we good? Do we have any questions about, all the stuff that we did today? No, 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 no. No bother. This is as up as we can go. You mean this side? Okay. Yeah, this is n over here. And n does not change. N is constantly just a 3. The other thing is that's also interesting is I do not use I in the inside the brackets unless I is already known to be less than n. Because when I becomes n, it is not a valid index anymore. Because in an array, the first item has an index of 0. The last item has an index of the number of elements minus 1. So in the case of you have 3 elements in the array, the index of the last element is 2. And that's because we are counting from 0. We are not counting from 1. All right. So I'm going to ask a few questions of a similar type question, but you can see the complexity or what I'm really checking are different. The first one is a very simple, okay? We're calling, we're returning, we're calling, we're returning. No recursion, no parameter, no local variable whatsoever. The second one does not even have a function other than main itself, okay? It's a control structure kind of question. The third one is more complicated. It is recursive. We do have arrays involved in this case. So, I will ask you basically a variety of, different questions. Each one is testing, a kind of either a specific concept or, they are ranked in terms of difficulty. So I'll give you something that's easier, at least in my mind, and something that is a little bit more challenging. Like this one, I would say is slightly challenging. So that's kind of the way I'm going to structure the test is to give you several traces, and then you just have to reverse engineer back into the source code with each one. All right. So I don't think um, you'll be really busy writing, because if I were to give you the code like this and then ask you to produce the trace, then yes, it'll be like a massive amount of writing, making sure that you have all the columns, formatted correctly and whatnot. But the reverse is actually not a whole lot of typing or writing. It's more about understanding the concept and applying reasoning and go like, okay, what is on this line? The trace tells me that something is changed on this line here, and what can possibly cause that to happen? Okay, so that's basically what you need to do, is to be able to go forward first, because if you don't know how to write the trace, there's no way you can reverse my trace back into the source code. So you have to make sure that you can trace algorithms first. And all the homework assignments, even though I haven't graded a whole, the last few, I have given you the solution already of every single one. So that would be a good starting point. A good starting point is to compare what you turn in with my solution. If they are the same, good. Okay, you got it down already. If they are different, then you need to look at the differences, and then you ask, okay, why is it different from text trace? Okay, and if you can explain that and go like, oh, I forgot about, um, when we set up the return column, it also has to include the line number and everything on that line except for the call that you're taking care of at that point in time. So if you just kind of put in like something but not the entire thing, like in this case, if you just put in a single question mark here, you just have to remind yourself, oh, okay, I have to specify the entire line with only the function call replaced by a single question mark. Okay, so you can diagnose your own submission in the homework assignment by comparing that to my solution. And I still have office hours. Okay, so that means, if you need to talk to me about, okay, I'm not really sure how to do this, you know, come to my office hour and I can help further explain the concepts. All right. So I do have one kind of business to take care of. I have been trying to contact a particular person in this class, and that person has not replied back to me. Um, I think last name is Garcia. First name is I cannot remember. Hmm? Say again? Go ahead. All right. No, it's not you. It's not Junior. Oh, okay. Let me look it up because I do need to talk to that person. And if that person doesn't talk to me, then I have to do something. I have to make certain assumptions, which I do not want to make. Okay, give me a second. I just want to make sure that I get that down. Actually, I can do the. I can do it here. I can look at all the people. This doesn't show the grades of anyone, so you don't have to worry about your grades being shown to the whole class. Okay, and then I just look for Garcia. Sergio, that's it. Okay. So Sergio, if you are here right now, please talk to me after class because I got something that I need to talk to you about. And apparently, Sergio is not in this class room right now and has not been in this classroom for the past few classes too. Anyway, so that's the end of today's lecture. We are done with lecture for this entire semester. So we only got the final exam to go. And hopefully this helps to prepare you for CISP 360, which I think it does, but you can tell me next semester. You can come back to me and go like, Tech, nothing you taught has anything to do with CISP 360. I want my refund. You can you can ask. You can always ask. I can just say that I'm sorry, I don't have the money. Yep, you too. Just don't forget, I still have office hours, okay? So in case you guys need to talk about things, I'm still available. All right, stop recording.